Joey Sophomoroni borrows his mom's minivan and goes for a little drive. This is a map of his journey as he leaves the house, takes a few turns, and hits a fire hydrant, bringing his little adventure to an end. At several places along this path, I've indicated his instantaneous velocity, his velocity at that moment. So his velocity vector has a direction indicating the direction of travel at that particular instant. And the length of the vector, the magnitude of it, that represents his speed, how fast he was going at that moment. So we see that he starts out with a relatively short arrow here, meaning he starts out going slow. Then on this straightaway, he picks up speed. His arrow is longer. Then Joey does make one sensible decision and slows down slightly going into this turn. You see that his arrow is shorter here. He's slowed down while making this turn, and then he speeds up coming out of the turn. Going through this larger turn, he keeps a relatively constant speed. The length of the arrow is pretty much the same, but its direction is changing this whole time. Now, we can see that his instantaneous velocity has two components, x component and y component. Let's draw those in at a few places. Moving along this part here, he's not moving in the x direction at all. So let's say at this particular moment, the x component of his velocity is 0. But the y component of his velocity, he's moving in the negative y direction. His y coordinate is decreasing. So we can say that the y component would be less than 0 at this moment right here. Let's jump over to this moment here. Joey's moving in the positive x direction and in the positive y direction. So this leg here representing his x component, that's going to be a positive value, and this leg representing his y component, also positive, right there. Jump up to this moment here. At this instant, he's moving only in the x direction, in the positive x direction. His y coordinate is not changing at that instant. So we can say that here, the x component is greater than 0, but the y component is 0. At this moment, his y coordinate is decreasing. He's moving down, his y coordinate is decreasing, so Vy is negative, but he's still moving in the positive x direction. So his x component is positive, while his y component is negative. At this moment here, his y component is negative, and his x component is also negative. He's turned around, and his x coordinate is decreasing once again. Then lastly, after he hits the fire hydrant, his velocity is 0. Both components would be 0. So what we mean by speed, instantaneous speed, is exactly the magnitude of this velocity vector, found by using Pythagorean theorem and adding up the components. So speed is the magnitude of velocity. It's a scalar, velocity is a vector. So the velocity vector has two parts, a magnitude, which is its speed, and its direction. Velocity has a direction, speed does not. Speed is just the number that you would read off of your off of your speedometer at that instant. Just the number on your speedometer, that's your speed. But you take that and include the direction of your travel, and that gets you your velocity.